Hello everyone, welcome to Green Learner. We are looking into the new feature in JDK 13. So in this video, it's time we look at the next feature that is being introduced in JDK 13, which is the Legacy Socket API, which is about the Legacy Socket API implementation. Earlier, we were using the plain Socket IMPL, which is there, right? It's pretty old, and I think it is from the starting of the Java when it started initially, right? So we are using the same one, and in certain scenario we have to tweak it, and we have to go around this to specify the certain scenarios, right? So the new implementation has been introduced, which is the NIO socket IMPL. If you are using JDK 13 and you are using the socket programming, so for socket API the default implementation is going to use NIO socket IMPL in JDK 13. Still, we have the option to switch back to the plain socket IMPL, which we can use by setting a flag. Right, I'll show you how you will do that. Right, let's go ahead and look into more about this legacy socket IMPL, what has been the motivation and how we can use it effectively in IO socket IMPL. Right, so let's go ahead and get started. So this is the link JEP 353, which is Java Enhancement Proposal, re-implement the legacy socket API, where you can get all the details related to this implementation, from where it is coming and why it is being introduced. So we are going to go through this line by line to understand this deeply, right? So this is the summary replacing the underlying implementation used by this socket and server socket APIs with the simpler and more modern implementation that is easy to maintain and debug. The new implementation will be easy to adapt to work with the non-user mode threads, right? Also known as fibers. So they are also known as fibers. This is being explored in Project Loom, so you can go ahead and look into more about this Project Loom, right? So this is the thing, fiber continuation and tail calls for the JVM, right? So we are moving ahead to motivation and what has motivated and what is the driving factor for this. So server socket APIs and their underlying implementation, they date back to 1.0. I already told you they are starting from the starting of the Java. The implementation is a mix of legacy Java and C code. So legacy Java code and also native libraries, that is C, and it is painful to maintain and debug. The implementation uses the thread stacks as the IO buffer, right? An approach that has required increasing the default thread stack size on several occasions. The implementation uses a native data structure to support asynchronous close, a source of subtle reliability and porting issues over the years. So you see the issue of maintaining and debugging the code when you're using the old implementation. So this is the main driving factor behind this, and adapting to the modern situation, modern hardwares that we are seeing. So using those is really a cool thing, right? So NIO socket IMPL was really coming on the way. So moving to the description part, socket API, it delegates all the socket operations on socket IMPL. It is a server SPI, server provider interface mechanism, that is existed since JDK 1.0, right? So the built-in implementation is done a plain implementation. It is clear from the name plain socket IMPL. It is extended by two other JDK internal implementation, that is support connects through SOCKS and HTTP proxy server. So SOCKS and HTTP proxy server, they are basically, so let's go ahead and see more about the SOCKS and HTTP. These are the new terminology and comparing with HTTP, right? So SOCKS is an internet protocol that exchanges network packets between a client and a server through proxy servers. So it is not connecting, it is not communication is between client and server, but it is not direct. So let me explain you. So if it is a client, right, it is a server, okay, client, and here we have server, right? So usually what happens, the communication between these are there. So when client something needs, it requests for in the server. So in case of SOCKAS protocol, this communication happens, but it is happening through a proxy, right? Not directly through this the channel is, so server is not going to know actually from where the request is coming, because it is going through proxy, and proxy is going to contact with server, and client doesn't have to know where the server is. So Client doesn't has to know where the server is. He needs to know the proxy details only, and proxy will ultimately connect to the server and perform the communication, right? So moving ahead, so it is additionally provides authentication, so only authorized users may access a server. Practically, SOCKS server proxies TCP connection to an arbitrary IP address and provides a mean for UDP packets to be forwarded, right? So when you are using proxy, we get a lot of security and other features where in direct communication we are not able to get, right? So moving ahead, more about differences in SOCKS and HTTP. For example, Bill is a name. It wishes to communicate the Zane over the internet, but a firewall between them exists on his network where Bill is not authorized to communicate with Zane directly. So Bill connects to SOCKS proxy on his network, informing it about the connection he wishes to make it to Zane. The SOCKS proxy opens a connection through the firewall and facilitates the communication between Bill and Zane. Okay, let me explain you more. So here is Bill, right? He wants to communicate with this server, right? But there is a firewall between this and this. With this system, he directly cannot communicate with the server, right? But he can contact a proxy service which has authorization to contact with the server, right? So what Bill does, Bill connects to the server, Bill connects to the proxy, and proxy ultimately connects to the server. So this is communication is happening, right? So next, what is HTTP? Bill wishes to download a web page from Zane who runs a web server. Bill cannot directly connect to Zane server as a firewall has been put in place on his network. In order to communicate with the server, Bill connect to his network HTTP proxy. His web browser communicates with proxy in exactly the same way that it would directly with Zane server if that were possible. That is, it sends a standard HTTP request set and the HTTP proxy connects to Zane server, right, and then transmit back to Bill and any data than Zane server. So if you were working in an enterprise company or any company, so you may be seeing this situation of the adding the proxy when you are connecting to the internet or client system, right? So this proxy works that way, right? So coming to our this legacy implementation, right? The new implementation, which is NIO socket IMPL, is a drop-in replacement for plain socket IMPL, right? It is developed to be easy to maintain and debug. It shares the same JDK internal infrastructure as the new IO, right? Implementation, so it doesn't need its own native code like we were needing in plain socket IMPL, the C code, right? It integrates with the existing buffer cache mechanism so that it doesn't need to use the thread stack for IO. It uses concurrent locks rather than synchronized method. So locks are a modern thing. So that it can play well with the fibers in the future. In JDK 1.1, the NIO socket channel and other selectable channel implementation were mostly re-implemented with the same goal in mind. Removing the native codes so that we can code directly in the code in Java directly, right? So the following are the few points about the new implementation. Socket IMPL is a legacy SPI mechanism and is very underspecified, and the new implementation attempts to be compatible with the old implementation by emulating unspecified behavior and exception where applicable. The risk and assumption section will see below section, right? Socket operations using timeouts are implemented by changing the socket to non-blocking mode and polling the socket so that it is not blocked on one thread and when it's serving the request. Okay, so cleaner mechanism is used to close sockets when socket IMPL is garbage collected and the socket has not been explicitly closed. Connection reset handling is implemented in the same way as the old implementation so that it attempts to read after a connection reset we fail consistently, right? So server socket is modified to use an IO socket IMPL. By default, it no longer uses SOCKS, the SOCKS implementation that it was using earlier, right? So if you read more about this, it is the detail about the NIO socket IMPL that we have. So this is the testing details, what needs to be performed internally when introducing this NIO socket IMPL. This is the internal to Oracle, how they have done the testing and all those stuffs. And this is section is about the risk and assumption. You can go ahead and see this. So risk and assumptions means the new feature that they are introducing. It should not introduce new bug, and it should exactly work the way plain socket IMPL was working for the outside world, right, for the user, right? And at the same time also improving the efficiency and other stuffs as well, right? So this closing socket with 100, so you can go ahead with these points. This is very much in detail, right? So in summary, I have explained you all about this socket IMPL, right? So this is all. This is the link. I'll give this in description box also. You can directly go there and see about it, right? So this was all about this Java enhancement proposal number 353, re-implementing the legacy socket API, right? I'll see you in the next video with the next feature that has been introduced in JDK 1.3. Maybe about we will be seeing ZGC, Z garbage collector, right? So I'll see you in the next video. Take care. Bye bye.